Go to stack, go to test. Yeah, select zoom interval, Z interval or zoom interval. Okay, the standard deviation is 0.25, 13.3. Sample size is very big, 389. Confidence level is 95. Okay. So you got the population mean. Predicted population mean is lowest is 13.275, highest is 13.325. So if we want to make it as equal, so this one we will round up 13.28 and this one we will round down. I will prefer to do it like that. If you want to round accordingly, I won't say it's wrong as well for this case. So when we talk about money, we usually round off to two decimal place. Okay, if you want to put 3 also can, if you put 2, it also can. Yeah. Okay, so we will say we are 95% confidence that the true population mean price for bottles of wine from this store can go as low as $13.28 and can go as high as 13.33. Okay, for part B, I will prefer you, for me, when I phrase the question, I will not use the word except. So can you please cancel except? So I will say, is there sufficient evidence? I will put it like that. Is there sufficient evidence not to reject? I will not use the word except because you are not 100% sure. It's just that this evidence only. Okay, is there sufficient evidence not to reject that the claim, okay, that the mean price has fallen? Okay, so this should be the question. Try not in whatever is it. Please don't use that word. Cancel off. Okay, now, is there sufficient evidence not to reject that the mean price has fallen? Is there sufficient evidence not to reject? Yes or no? The original mean price for the past 12 months is 13.45. So based on this, and look, is there sufficient evidence not to reject? Yeah. So the answer is yes. Okay, why? Yes, we have insufficient evidence to reject the claim that say that the mean price has fallen because is there sufficient evidence not to reject? That means we have insufficient evidence to reject. If you say you have insufficient evidence to reject, that means this evidence doesn't allow you to reject. Okay, we have insufficient evidence to reject that the mean price has fallen Because who can explain faster? Okay, we continue. Ethan, your turn. Because what?
Because the highest possible predicted mean value is $13.32, which is lower than $13.45.
Yes, because the highest predicted mean price is 13 point. Even I put 3 also doesn't matter, which is less than 13.45. So we cannot reject. So the claim, we have insufficient evidence to reject the claim. But I cannot say the claim is right. It's just that this sample mean don't allow me to reject. If I get another sample mean, I don't know. Do you get me? Hello? So now, I'm going to ask you an extra question like that. I see whether you know how to do or not. Okay? Okay, I will go to part C. Based on the 95% confidence interval from part A, find the highest probability okay, can go. Find the highest probability that a bottle of wine from this store, the price is more than 14. Okay, so how to do this type of question? So I'm going to explain. So I'm going to explain to you that when I say based on the 95% confidence interval, that means I'm telling you, in this question, I'm talking about the population, okay? So I'm telling you that my population mean I can have a population, okay? My lowest population mean will be 13.28. So I can have a population like that. So we will look at the extreme value. So this is my population I'm talking about. So this is the price. So you can have the mean of 13.28. So this is one of the possible distribution. So they can have many population distribution of different mean, but it range from 13.28, standard deviation still the same, 0.25. So I can have many, and the other one, the highest, with the highest mean, it will be like that. The mean is 13.33. Okay, So this is another one. So they can have many distribution. This is the population. So that is how you interpret the confidence interval, the predicted population mean. So that means I can take any mean between these two values. Okay, so now I'm talking about the price of a bottle is 14, right? So if you look, this is 13.28, 14 will be here, right? This is 13.33, so 14 will be nearer to 13.33. So now you tell me, which one will have a greater area? So that's why I have the highest probability. So depend on the question, your experience in the SAT 5, correct? Do you see I changed the question? So you have to read the question. So find the highest probability that a bottle of wine from the store, the price is more than so. I will take this distribution. Hello? So I will take this distribution. So I will find the probability that my X is more than 14. So I will put into normal CDF. If I say the price is normally distributed, if right from the very beginning, I said the price is normally distributed, okay? So I'm just telling you, so it will, it's not the mean price, it's the price, so 14. 10 to the power 99. You take the mean as 13.33 and the standard deviation is 0.25. So in this case, you have to be very careful. You are talking about population. So your standard deviation must be right. So are you clear? So if I say based on the 95% confidence interval, that means I'm telling you the population standard deviation can take any value between here. Clear? Hello? If I change this question to the lowest probability, then you have to take this one. This population mean will create lowest possible probability for this case. And this, the higher end. Are you okay? Can someone respond to me, okay or not okay? Okay,
Yes.
So always remember, if I say based on the confidence interval given, calculated. So that means I'm telling you the population mean can take from the lowest possible value to the highest possible value. So that means you can have many means. Yeah. Okay or not? So when you write your report, you also can bring in things like that to show that you really understand what confidence interval is all about. Are you okay? So can someone give me the answer for this one? Normal. Normal CDF 14.
I got 0.0037.
0.0.
037.
0.037. Okay, now I just want to let you know, am I right?
0037.
Another 0, is it?
Yeah.
Yeah. If you are not sure, correct? You calculate both. You use the two extreme. mean and calculate both probability. Clear? If you are not sure during the exam, can or not? Okay. Shall we go to question 4? Okay, question 4 is a bit different. So every question here you have to do, okay? Question 4. Okay. So to improve, this is the past record, okay? So this is after 6 weeks. So after 6 weeks, okay, then you go, the sample size is 12. So is the sample size large enough to assume the sample mean distribution is normally distributed? Definitely, because the original is normally, the population itself is normally distributed, okay? So, and the sample mean that they get, one of the sample is now is 12.18. So we are going to use this point estimator to predict the possible population mean time, okay, for running 100 meter. So your parameter of interest is mean running time for 100 meter for Joanne. Am I right? Okay, so what is the mean running time? Confidence interval? Okay, someone have given me the answer already. So I'm going to call someone to give me the answer. Huynh, your turn. Huynh,
Yeah,
your turn, please.
we are 95%.
Okay, wait, I wait.
Oh.
12.18, I also doing, okay? N is 12. Confidence level is 95. I got already, you should get.
12.01 and 12.01.
Yeah. 12.01 and 12.35. Okay, now, how do you write it in words for this? We try. We are
95%. 95% confident that the population of mean time of Joanne can be as low as 12.01 and as high as the 12.35.
Second, you must put the unit. If you didn't put the unit, we will deduct your mark. Understand? So you have to put down the unit. So if I put 2 marks, then you have to interpret. Okay, good. Now, is there sufficient evidence? Okay, hence access the claim. Joanne times to run 100 meter has improved. Improve or not? Improve or not? Okay, Izu, Hakim. Answer B part 1. Hence, access the claim. Yuan time to run 100 meter has improved.
Not enough evidence to support the claim. Because the confidence interval is below 12.46 seconds.
Okay, if my highest possible mean time to run 100 meter is 12.35, isn't it lower than my previous mean, my past mean?
Sorry.
Mm.
It is within the confidence interval, so there is sufficient
Are you
evidence.
sure it's within the confidence interval? My confidence interval is here. You have to be very careful. When I read, I really read every single word that you say, okay? This is like those who study law. This is your confidence interval.
Yeah.
This is your old record. So,
Yeah, so it's higher
Hakim,
than confidence interval.
so please put it in words nicely. I want to force you until
The
you get
mean
the
time of 12.4 seconds is
okay.
above the
Every time,
confidence interval.
hold on. You don't talk about, you have to say we have sufficient evidence or insufficient evidence.
We have sufficient evidence that the running time is improved because the mean time of 12.46 seconds is higher than the confidence interval.
How can you say highest than the confidence interval?
The confidence interval is below the mean time.
Okay,
12.46
you try not to use the word confidence interval. You try to give me the value that you are comparing.
The interval of 12.01 and 12.35 is below 12.45. So we have sufficient evidence to support the claim that the running time has improved.
Okay. So if you put it in a simpler way, so we will say we have sufficient evidence that Joanne running time for 100 meter has improved because the highest predicted mean time is 12.35, which is less than 12.45 seconds. Right? So you must use a number to compare. You don't just say confidence interval, confidence interval. So statistic is you have to give me a number to compare. When generally, okay, there are some who explain like that because the whole confidence interval is below 12.45 seconds. So if you say the whole confidence interval is below the 12.45 seconds, correct. But do you give people the picture of numbers? So the way you explain the one, I up to you. I will not mark you wrong. If you say the whole confidence interval is below the previous mean time, that is 12.45. And you use this diagram to illustrate. So sometimes when you explain, correct, is illustrate the confidence interval and the claim that you want to say on a number line. So this one, we call it the confidence interval number line. Are you clear? So you use this illustration, so you give people the picture, so people can say, oh, yeah. So I understand that. So this is illustration is important also. Give people some visual. So from there, oh, they can judge, oh, that's why improve. You see or not? You use word, you also use this. So your presentation will be very understandable. People will be able to understand it easily. If you just use word, I have to figure out in my mind. If you read the picture with the number line, then people, oh, you pick it very nicely, then I can link. Are you okay? Hello? Can I? Okay, number part 2. Joanne is now faster than Betty, whose time for the 100 meter is 12.26. So Betty. Okay, Betty times is 12.26 seconds. So can I, based on the confidence interval in A, I conclude that Joanne is faster than Betty. Okay, so next one, we see who how. Okay, Amali, Muhammad Amali, your turn. I go by alphabetical order, okay?
Yes.
Yeah, please.
So
We have sufficient or insufficient evidence.
we have sufficient evidence to claim that Joanne is now faster than Betty, as the minimum or no, the lowest confidence interval is 12.01 seconds, which is less than 12.26 seconds for Betty.
So if you say like that, I will ask you this question, Amali. I will ask you this question. If what happened, the true population mean time for Joanne now is 12.35?
Then in that case, she would be slower.
So based on this confidence interval, so you have sufficient evidence to reject or not to reject. You have insufficient evidence to reject.
We have insufficient evidence to claim.
So you put it nicely.
Based on this confidence interval, we have insufficient evidence to claim that Joanne is faster than Betty,
Because?
Yes, as the highest value for the confidence interval is 12.35, which is still slower than Betty's 12.26 seconds.
So now you understand or not? Right, just now you compare with this one. So when you want to compare whether it's faster or not, any of this value is possible. Right? So if I illustrate this, that means these are all the possible mean for Joanne. It can be this, it can be anything between here. It can also be 12.35. So now Betty is here. This is for Joanne. All the possible mean for Joanne. So I write down there. I tell myself, these are all the possible mean running time for Joanne. So Betty is here. I use color. So Betty time is here. There is, oh, no, sorry. 12.26, sorry, 12.26. I see the wrong number, 12.26 second. Okay. So there is a chance that, you see, yeah, you compare here. You don't compare with this one. See or not? Hello? So you say we have sufficient evidence to reject the claim that say Joanne is now faster than Betty because the highest possible predicted mean running time for Joanne is 12.35, which is greater than 12.26 for Betty, second for Betty. Are you okay?
Yes.
Can or not? Okay. Zhang Zhenming want me to say it again. Why don't you say it again? Why don't you say it again? I write. Okay, Zhenming. Try. I will guide you. I will guide you. Because if I say again, no use one. You based on this picture, you say. Okay, Zhenming, we have sufficient evidence to reject the claim, to reject, if you want to reject that, also can, to reject that Joanne is now faster than Betty because you explain the highest predicted mean time for Joanne is 12.35, which is greater than, which is, if this case, we should say longer lah, than Betty time. It's better for me to write down, okay? That is 12.626. Okay? Can or not? Okay. Sufficient evidence to reject. That means you reject the claim. Insufficient evidence to reject. That means you say this evidence doesn't reject the claim. That doesn't mean the claim is true. It's just this evidence say it is true only. Another evidence may be different. That means if I take another samples and I find the sample mean, it may be, yeah. You just have to, you don't say complicated. So the only way to say is sufficient evidence to reject or insufficient evidence to reject. The only difference is here. If you put insufficient evidence to reject, so that means you say this evidence say the claim is okay. So you write down a note there. Insufficient evidence to reject means the claim is okay. Please don't write that in your report or in your exam. That is for you to know how to write. Are you okay? For you to remember. Okay, good. So can we go to question 5? So this is the claim. The claim here is decide to buy or not to buy. Okay, they will, if the mean weight is more than at least 60 grams, then they will buy. So now they take a sample. So sampling now. So the sample mean for how many? 60. So is this sample size large enough? So I keep mentioning, yes, because it is more than 30. So I don't care whether the original is that. So my sampling distribution will be normally distributed. Yeah, so grammar. And the sample standard deviation is 4.2 grams. We don't know the population standard deviation. So we assume this is the population standard deviation. Okay, the population is the prawns, the catch, 50,000 prawns. Okay, that is the population. Yeah. Okay, now using S to estimate that one, construct a 95% confidence interval. Okay, now everyone construct. So I'm going to ask someone to give me the answer. Standard deviation 4.2. Sample mean of 60 is 57.2. Sample size is 60. Confidence interval is 95. Okay. So do you get the answer? So whose turn? Rachel. Rachel, your turn. Rachel, give Miss Do the predicted population mean weight of prawns. Rachel,
Yeah, I'm still calculating.
you are still calculating. Do you know where to get the answer or not? You are using formula.
Yeah,
Why are you using the formula? Did I say must use formula in the question?
no,
No. So do you know how to use your GC or not? Rachel, do you have a GC?
yeah,
Okay. So you go to stack, go to test, and select number 7. So key in all the information already. Wow, I really have to call you all one by one. Very scary, all of you. Yes, Rachel, answer.
56.137.
53.137. 56, thank you.
58.263.
263. Okay. So Rachel, if you don't mind, can you put in words?
Yeah,
Put in words. Okay, I start for you, Eddie. We are 95% confident that
the mean weight
mean weight of what? Mean weight of what? You cannot just say mean weight. You say mean weight, I will not. We are 95% confident that the true population, someone prompted me, the true population mean weight of prawn some more, Rachel?
Is higher than
Is higher. Okay, some more.
$56.137 gram
Some more.
and lower than 58.26 gram.
Yeah, okay. We can also say we are 95% confident that the true population mean weight of prawns, okay, is higher than 56.137 gram and is lower than 58.263 gram. Also can. Are you clear? So the one I leave it to you. How you want to phrase it? Make sure you have the sense of the highest and the lowest. Okay, it can go as low as 56.137 gram and go as high as 58.263 gram. And if you want to say lie between, also can. Make sure you know these are all the possible predicted population mean. Are you okay? Okay, now, B, so I make sure I get all this right with you first. Okay, do you think that the buyer should purchase the catch? Do you think the buyer should purchase the catch? Explain your answer. Okay, do you think the buyer should? Sean Lee. Now your turn.
I think the buyer should not purchase the catch because there is sufficient evidence to reject the claim that the mean weight of the prawns is 60 grams. This is because the highest possible predicted mean weight is 58.2 grams, which is less than 60 grams.
Yeah. Do you all get it? So you can illustrate. This is the confidence interval. Someone say, well said, Sean. So you can get A+ for your SAT 6 already. This is the confidence interval that we get, 56.14, and this is 58.26. The claim say that the mean weight must be at least 60. So this is the claim. Whether to purchase or not to purchase. He said, if the mean weight of the prawn is at least 60, then only he will buy. So now his decision, not to buy. Okay. So do you think that the buyer should purchase? The answer is no, because we have sufficient evidence to reject. We have sufficient evidence not to purchase because the highest possible predicted population mean is 58.26, which is less than the minimum requirement of the weight of the mean weight of the prawn, that is 60 gram. So all are English, you just translate your max into English. Are you clear? So you can claim in any other way. You can use your own word, but make sure the meaning is there. Your comparison of the number must be there. Clear? Okay. I like to come up with a question here. What is the, hold on, what is the biggest I shouldn't say what is the biggest. What is the smallest? So that the buyer will purchase so that the buyer will buy the prawns A. What is the smallest sample mean so that the buyer will buy the prawns? So how are we going to solve this problem? So this, we know that this sample mean, so it's still 60, yeah? I still keep at my sample size as 60. So in this case, what we need is, we need the formula already. So what is the formula for prediction of the true population mean? This is the formula, correct? It depends on the sample mean, correct? Yeah, so we are going to, so that means if you were purchased, if it's at least 60, correct? That means this one must be 60 gram. This one can be, definitely will be higher than 60. Am I right? Is my analogy logic correct? What is the smallest sample mean so that the buyer will buy the prawns? So I have to look at the lower predicted, correct? As long as the lower predicted is more than 60, that means it's at least 60 already. Am I right? So, yeah. So now, can I? So you read the question. I tell you, I have all the question in mind. So okay. So now what I do is, this is the sample mean that I'm supposed to find. Take away 1.96. What is my standard deviation? 4.2 over square root of 60. So it must be at least 60 gram. Correct? So from there, I can count my sample mean. Are you okay? So that is how it works. As long as you understand the meaning of confidence interval, is the prediction, is the predicted value, is the possible value. Based on that sample mean, I make a prediction, or I tell you what are the possible population mean that will come true. Okay, so it will be 1.96 sampling error times, yeah. So it must be 61 point, okay, someone have calculated 61.067. So if you round up to 3 significant figure, it will be 61.1 gram. You try to put this into a confidence interval, then see whether it's correct or not. See whether the whole confidence interval is above 60 or not. Okay? So I try to use the example that you all have in your textbook and give you other example. So with this in mind, you should be able to do most of the question. Next week, I will discuss about your folio with you, okay? So that you can start working on it, because by the end of August, you have to submit your folio to me already. By the way, our max folio, anyone have read the question? How many pages? No one want to answer me, never mind. That means you haven't looked at the question yet. Okay, so the rest you will try to do it. Yeah. So tomorrow lesson, I will talk about sample proportion, okay? It's another part of it. Yeah, it's almost the same, but it's another, it's talking about proportion. So our parameter of interest is the population proportion. Yep. Okay. Thank you, class.
Thank you, Miss. Thank you, Miss.
Yeah, thank you, class.
Thank you, Miss.
Thank you, Miss.
Yeah.